Good morning, students. Yesterday we discussed about P block elements. In P block elements, we completed up to the preparation of nitric acid by Ostwald process. Nitric acid can also be prepared by any salt nitrate by treating it with concentrated sulfuric acid. And on a large scale, nitric acid can be prepared by Ostwald process. In Ostwald process, ammonia is oxidized. What are the conditions? So ammonia is oxidized in atmospheric air in the presence of catalyst platinum and rhodium at a temperature 500 Kelvin and a pressure of 9 bar. So ammonia is oxidized to nitric oxide. In second step, the nitric oxide is again oxidized to convert into nitrogen dioxide, and that nitrogen dioxide on treated with water, we will get nitric acid. So all the three steps, equation, everything we studied yesterday. So you have to write the equation, and from examination point of view, 3 marks question will be appear for the preparation of nitric acid by Ostwald process. Are you clear? Okay. Today we shall study some of the physical and chemical properties of nitric acid. So nitric acid, a planar structure, so it can easily dissolve in water. So therefore it is a strong acid. So its dissolution, nitric acid. Water. So you will get see nitrate ion NO3 minus, which is aqueous, and plus H3O plus and hydronium ion, which is aqueous. So therefore it is a strong acid. It is a colorless liquid. In the laboratory you can find by the oxidation a little bit yellow color. So it is nothing but nitric acid. When you add when it treated with water, so nitrate ion and H3O plus hydronium ion is released. It indicates it is a strong acid. It is corrosive at all. Okay, you have to study some important chemical properties. How nitric acid reacts with the metals, even in concentrated and in the dilute condition. So this nitric acid reacts with zinc. See, zinc reacts with nitric acid. 10HNO3, which is in the dilute condition. So you will get zinc nitrate. So you can balance it by 4 atoms of zinc reacts with 10 molecules of nitric acid, and you will get 4 Z10 NO3 twice zinc nitrate, and you will get N2O, which is nothing but dinitrogen oxide, and we shall balance it. So you have 8, so therefore it is N2O, and then again 5H2. So zinc reacts with the dilute nitric acid, and again the zinc reacts with concentrated nitric acid. You will get again zinc nitrate. So which is nothing but 4 molecules again. So you have 4 NO. So when it reacts with concentrated nitric acid, we will get nitrogen dioxide, the brown gas, evaporation of the brown gas. Again plus 2 H2. Therefore, nitric acid reacts in the dilute condition as well as in concentrated condition with many metals. Particularly, it reacts with zinc. In concentrated condition, it gives nitrogen dioxide. Like that, it reacts with copper, reaction with copper. See, copper reacts with concentrated nitric acid, concentrated nitric acid 4 times. You will get CuNO3 twice plus 2H2O plus again 4NO. See, we can NO to nitrogen dioxide gas, just we can balance here. See, one nitrate, two nitrogen, not more here, two nitrogen here also, two. See, four nitrogen atoms are there, two nitrogen used here, zinc nitrate, and that one is 2NO. Like that, there are also 2NO. Just see the number of atoms. I'll repeat again. See, zinc reacts with concentrated nitric acid. Concentrated nitric acid. You will get zinc nitrate and 2NO, not 4NO here. Check the number of nitrogen atoms, 4 nitrogen atoms in nitric acid, and 2 are used in zinc nitrate, and 2 remains, therefore it is 2NO plus 2NO. Like that, copper reaction concentrated HF3. So we will get copper nitrate, which is equal to CuNO3 twice 2 nitrogen atom here, and again 2 nitrogen atom in the form of nitrogen dioxide. You will get one more question. Only one more question can be asked. So name the gas liberated when copper reacts with concentrated nitric acid. The gas liberated is nitrogen dioxide. Brown color gas is evaporated. So some of these reactions we studied in lab also. We shall react. This is very important. Reactions of concentrated nitric acid. So concentrated nitric acid, again, which is a strong acid, it can easily oxidize. It is a strong acid because it can easily oxidize. So we have to study what are the uses of nitric acid. Nitric acid can be used in preparation of ammonium nitrate and even in analytical laboratory. So many uses we can find. Even it can also react with non-metals also. It can also react with non-metals. See, it can react with carbon and carbon dioxide gas releases. It can react with iodine. Iodic acid is obtained. Even it can react with sulfur. Sulfuric acid is obtained. Are you clear? It can react with non-metals also. But very few metals, it forms a film of oxide. For example, this concentrated nitric acid reacts with metals like chromium and aluminium, and the reaction it forms an oxide film. Therefore, the reaction does not take place. Particularly in chromium and aluminium, it forms an oxide film. Are you clear? So, which can be asked for 1 mark. Even nitric acid reacts with, in concentrated condition, non-metals also. So it reacts with iodine, we will get iodic acid. It reacts with sulfur, we will get sulfuric acid. It reacts with, again it reacts with carbon, we will get carbon dioxide. Are you clear? Okay, some of the important reactions are there. Take for example, it reacts with carbon, concentrated HNO3. So which is in 4 times. So you will get carbon dioxide gas plus water molecule. This balance, so these are 12. Here 2 carbon, 2 oxygen atom, and here 2 plus you will get NO gas. Okay, this is the 4N. So in all non-metals, it reacts with and gives nitrogen dioxide, which is nothing but a brown color gas. And the non-metal is oxidized to carbon dioxide. Like that, you will get it reacts with iodine, even it reacts with sulfur. Take for example, sulfur, which is a polyatomic escape. When it reacts with nitric acid. So you will get sulfuric acid, H2SO4. You can balance here. So 48 HNO3, 8 sulfuric acid molecule plus you will get 48 nitrogen atom, therefore it is nothing but 48 NO2. And how many hydrogen atom remains? You can easily balance the equation just to see the number of atoms in reactant side and the product side. So this is a molecular sulfur which is polyatomic SA. It reacts with 48 molecules of nitric acid. That means to balance this equation, it reacts with nitric acid. So you will get sulfuric acid. How many sulfur atoms are there? 8 sulfur atoms are. Therefore, it is 8 H2SO, not 4. How many sulfur atoms are there? 8. So therefore, it is 8 H2SO. Are you clear? By writing, just write the product and see check the number of moles easily with balance. 8 H2SO, then 48 nitrogen dioxide, which is a brown color gas, and balance for hydrogen atom. Here it is 16, 32 remains, therefore it is 16 H2. Are you clear? Okay, easily you can balance. So nitric acid, oxidize sulfur into sulfuric acid. Sulfur into sulfuric acid. What is the equation? So you will get SA 48 HNO3, 8 H2SO4 plus 48 NO2 plus 16 H2. In P block elements, many reactions are there. You have to balance it. Very easy. But remember what are the reactants and products. Just to look into it, you can easily balance it. Repeatedly, you have to write the equation. That's it. Okay. The thing you have to remember is nitric acid reacts with non-metals, it oxidizes. Carbon into carbon dioxide, sulfur into sulfuric acid, even iodine into iodic acid, HiO3. And even it can also react with phosphorus in the phosphoric acid. Okay, some reactions I know. So that is nothing but the nitric acid. We are complete our discussion on nitric acid. Are you clear? Okay, preparation of nitric acid, very important one by Westphal process. It's a chemical reaction with zinc and copper, and it's chemical. It reacts with zinc in a dilute condition. Are you clear? It gives N2 and reacts with copper. It will give NO in dilute condition, nitric oxide. In concentrated condition, copper and zinc. So yellow color nitrogen dioxide gas is. Brown color, not yellow color. Brown color nitrogen dioxide gas is given. Okay, so that is nothing but the reaction of nitric acid with non-metals. So generally you have to remember it reacts with metals and non-metals, and particularly elements like chromium and aluminium, it forms some oxide film. Okay, then we shall continue our discussion of phosphorus. We completed nitrogen and its compound. Nitrogen, dinitrogen, ammonia and nitric acid. And we have to study phosphorus and its compound. So in phosphorus, which is nothing but again a polyatomic and second element after nitrogen in 15th group. So we have this phosphorus. So phosphorus exists according to your syllabus. You have to study red phosphorus and white phosphorus. Their difference. Simple question can be asked. Differentiate between or write any three difference between white phosphorus and red phosphorus. So remember some points. Phosphorus, it is nothing but a polyatomic and it can be represented as P4. It exists as white phosphorus, red phosphorus. Concentrate on this only. So again it forms in many allotropic forms. We shall discuss later on. White phosphorus, it is poisonous and it shows luminescence. So that it can show, it can glow. That particular property is called chemiluminescence. Are you clear? So in the room temperature only it can glow, and it is poisonous. It is insoluble in water, but soluble in carbon disulfide. So it is highly reactive. It is highly reactive due to its strain in the molecule. So it is nothing but its structure. So you can find phosphorus atom, 4 phosphorus atom, 4, where the angle strain you can find nearly 6 to devote to it is sp3 hybridized orbital. So here P4 in each P atom is angle strain we can find, therefore it is highly reactive. So you go for red phosphorus, red phosphorus. So red phosphorus can be prepared by white phosphorus on heating nearly at say white phosphorus converted into red phosphorus by heating this nearly at 573 Kelvin temperature in an inert atmosphere. Inert atmosphere. So it is a white translucent solid, but here it is a red grey color solid. It is poisonous, it is non-poisonous, and it is highly reactive. It is not reactive at room temperature. So this reacts with the air room temperature P4 when it reacts with oxygen, and you will get phosphorus pentoxide, you can see P4 open fumes of phosphorus pentoxide. This balancing. So P4 plus 5O2, and in the room temperature you will get phosphorus pentoxide. And this red phosphorus is not poisonous. It cannot react at room temperature. It is not poisonous. Why? You have to remember its structure. See, structurally it can dimerize. It can dimerize as well. You can see it is nothing but 4 phosphorus atoms, and here also again 4 phosphorus atom, and which can dimerize easily. So therefore, it is not highly reactive as white phosphorus. So it can dimerize, but we cannot find a dimerization in white phosphorus. So this red phosphorus is less reactive and white phosphorus is more reactive. With this red phosphorus, it is not soluble even in water and carbon dioxide. So what are the major differences you have to write in your examination? Okay, how red phosphorus is prepared? Red phosphorus is prepared by heating white phosphorus at 573 Kelvin in an inert atmosphere. So you have to wait for several days, nearly 1 week. So it gets converted into red phosphorus. So another important difference you have to remember is, see, it is a white translucent solid, shiny. It shows chemiluminescence. That means it can glow. Then, so we cannot find chemiluminescence in red phosphorus. In air, it burns as phosphorus pentoxide. Okay. So you can have to remember one important chemical property of white phosphorus. When it reacts with a concentrated solution of any liquid, so you will get. See, when it is boiled with concentrated solution of P4, when it is boiled with concentrated solution of NaOH, along with water, 3H2O, you have the chemical phosphine gas is prepared. You can see. See, this is the white phosphorus. When it reacted with concentrated solution of sodium hydroxide, 3NaOH, it is boiled. So you will get, see, phosphine gas, PH3 gas. Again, we have to study in the phosphine gas. We have to study. Again, 3 Na, P2, Na, H2, PO. Sodium hypophosphite. Sodium hypophosphite. Can you see the reaction? White phosphorus, when it is boiled with a concentrated solution of sodium hydroxide, you will get phosphine gas. Phosphine gas. So this is an important chemical property of white phosphorus. Say that is nothing but 3NaH2PO2, sodium hypophosphite. Okay. So you studied the difference between red phosphorus and white phosphorus. I will repeat again. So red phosphorus, which is a translucent, a shiny solid, and red phosphorus is a red grey color solid. White phosphorus is poisonous. Red phosphorus is non-poisonous. White phosphorus is highly reactive. It burns in air to form phosphorus pentoxide, huge fumes, and red phosphorus does not react at room temperature. So high temperature it can react. So these are the major differences between red phosphorus and white phosphorus. Simple question can be asked. Okay. So you go for structure of red phosphorus. So it has an angular strain, bond angle reduced to 60 degree. So therefore it is highly reactive. Even though red phosphorus having an angular strain, due to its dimerization, more molecules unite each other. So therefore it is less reactive. Okay. When white phosphorus is boiled with concentrated solution of NaOH, we will get phosphine gas. We will get phosphine gas. Okay, these are the important points I have to remember about white phosphorus and red phosphorus. Again, we have when the red phosphorus is heated or white phosphorus is heated at different temperature, different allotropic forms of phosphorus are obtained. So, according to your syllabus, you have to remember two forms. That is, one is alpha black phosphorus. Another one is beta black phosphorus. Okay, one is alpha black phosphorus. Another one is beta black phosphorus. So alpha black phosphorus is obtained by heating red phosphorus. By heating red phosphorus at nearly 803 Kelvin temperature. So you will get alpha black phosphorus. When red phosphorus is heated nearly at 803 Kelvin temperature, it gets converted into alpha black phosphorus. And again, beta black phosphorus is obtained by heating white phosphorus. By heating white phosphorus nearly at 473 Kelvin temperature. Nearly at 473 Kelvin temperature. So, what are the other two forms of black phosphorus? One is alpha black phosphorus, another one is beta black phosphorus. So, alpha black phosphorus is obtained by heating red phosphorus at a temperature 803 Kelvin. Like that, beta black phosphorus is obtained by heating white phosphorus at nearly 473 Kelvin temperature. What are the characteristics? So, both are stable at room temperature. At high temperature, they can react, but they are stable, used in different applications you can find. Okay, here both alpha black phosphorus and beta black phosphorus, both are allotropic forms of phosphorus. So, you studied white phosphorus, red phosphorus, again alpha black phosphorus and beta black phosphorus. These are stable forms. Only white phosphorus is reacting at room temperature due to its angle strain. Strain in the molecular chemical. Okay. See students, what you understood repeatedly I am going to tell you. In phosphorus, you studied white phosphorus and red phosphorus. Again, alpha black phosphorus and beta black phosphorus. You have to study another important compound of phosphorus. So, which is the phosphine gas. Phosphine gas. Phosphine. Phosphine gas. Phosphine. Which is a poisonous gas. Phosphine gas. pH3. What is the formula for phosphine gas? So it is a colorless poisonous gas. So we shall study how we can prepare this phosphine gas. So it can be prepared by calcium phosphide, Ca3P2 calcium phosphide. So when it is treated with water or hydrolyze, so you will get 3 CaOH twice calcium hydroxide and plus 2 pH3. Just see the reaction. How many hydrogen atoms are there? 6. 6 hydrogen atoms in phosphine gas it is consumed. How many phosphorus atoms are there? 2. So it is 2 pH3. How many calcium atoms are there? 3. So therefore it is 3 CaOH twice calcium hydroxide. Are you clear? Oh. So this is nothing but this is nothing but the preparation. Even this calcium phosphide again treated with even with HCl, when treated with HCl, hydrochloric acid. See Ca3P2. So you will get 6HCl. Calcium phosphide when it is treated with hydrochloric acid, again you will get 3 CaCl2 calcium chloride salt and then 2 pH3, which is nothing but a phosphine gas. So important again, you already studied how phosphine gas is obtained by boiling with a concentrated solution of NaOH in inert atmosphere. See, when white phosphorus is boiled with a concentrated solution of NaOH, a concentrated solution of NaOH with 3H2O, you studied one of the important property of white phosphorus. So, a boiling solution in presence of an inert atmosphere of carbon dioxide. So, you will get phosphine gas. pH3 plus 3 NaH2PO, sodium hypophosphite. So, these are the important 3 methods for the preparation of phosphine. Are you clear? What are the important properties of phosphine gas? The preparation of phosphine gas. One is with calcium phosphide. When it reacts with 3 molecules hydrolyzed, nothing but the hydrolysis. So you will get calcium hydroxide and phosphine. So here again calcium phosphide reacts with hydrochloric acid. We will get calcium chloride and phosphine. When phosphorus again white phosphorus, so it is white phosphorus. When it is boiled with a strong solution of NaOH in an inert atmosphere, so we will get phosphine gas. Are you clear? So these are important, the 3 preparation of phosphine. How phosphine gas is prepared from white phosphorus. You may ask 2 marks question. Write chemical equation. When white phosphorus is boiled with a concentrated solution of NaOH in an inert atmosphere of carbon dioxide, so we will get phosphine gas. Are you clear? How phosphine gas is prepared from calcium phosphide? So we can prepare by 2 ways. One is when calcium phosphide is treated with hydrochloric acid, we have the equation Ca3P2 plus 6HCl, you will get 3 CaCl2 plus 2 pH3. Again, calcium phosphide reacts with 3H4, you will get calcium hydroxide and phosphine gas. See, repeatedly, again and again, I am going to tell the reaction. You have to practice it. and you must know the reactant and the product. Easily you can write. Formulas you have to get it. Phosphine pH 3, calcium hydroxide CaOH twice. Everything you studied in first PUC. Different types of basic and acid radicals, how the valency can be transferred. So you have to apply this principle. Okay, phosphate, its physical property. So phosphine is a colorless, poisonous gas. More foul smell of fishy smell, which cannot be tolerated. The foul smell, bad smell. It's a poisonous gas. And chemically it can easily oxidize. It can easily oxidize. So even it can explode by oxidizing it like nitric acid, even in chlorine, bromine. So these are some of its chemical properties. It can easily explode. It can easily catch fire in the presence of an oxidizing agent like nitric acid. So these are the important chemical properties of phosphine gas. And phosphine gas is used. Phosphine gas is used. It is used in Helmholtz signals. Helmholtz signals means when the mixture of phosphine and calcium phosphide is mixed, and when water is made to drop on it, it gives a large amount of smoke. So in sea divers, in order to identify the ships, and that particular is called almost signal. It's called almost signal. You can use it there. So this is nothing but about the phosphine gas. Are you clear? You have to study. Next important compound of phosphorus is phosphorus trichloride and phosphorus pentachloride. So we shall study next important compound of phosphorus, that is phosphorus trichloride and phosphorus pentachloride. So what about phosphorus trichloride PCl3 and PCl5? PCl5. Phosphorus trichloride and phosphorus pentachloride. See, both can be obtained by heating white phosphorus, with the chlorine gas. So you will get 4 PCl3. So therefore it is 6 Cl2. Earlier, when chlorine gas is passed through white phosphorus trichloride. Like when white phosphorus is treated with again excess of chlorine gas, so you will get 4 PCl5. So when it is on it is 10 Cl2. On passing chlorine gas, phosphorus trichloride as well as phosphorus pentachloride can be prepared. Okay. See, it can also be prepared by thionite. It can also be prepared by thionite. What is the formula for thionite chloride? See, white phosphorus very reaction. Thionite chloride, SO2Cl2, SO2Cl2. So we will get 4 PCl3, which is the phosphorus trichloride, and we will get SO2 gas, and along with 2 S2Cl2. So which is nothing but, so therefore how many we have to balance this? 8 chlorine atoms, therefore there is a 12. So therefore it is S2Cl2. See here 12, we shall balance it. It can also be prepared by what? Thionite chloride. What is the formula for thionite chloride? SO2Cl2. See, P4 plus 8S4 So you get 4 PCl3, 4 PCl3. Can you see the equation? Okay. Then again, sulfur dioxide gas, and disulfur dichloride, which will balance this here. So P4 there is a 12 chlorine atom, and here 16. So therefore it is 2Cl2. Here 12 and here 4. How much? 16 sulfur, right? 4 phosphorus atom and sulfur atoms again here 4 and 8. It should be 4 S4. 4 to the 8. 8 oxygen atom. So here 4 is the 8 oxygen atom. So this is nothing but the equation. Are you clear? You can easily balance. I'll repeat again. See, white phosphorus, when it is treated with sulfuride chloride, which is obtained by the continuous gas passing more into concentrated sulfuric acid, the 2 hydroxyl group of the sulfuric acid replaced by chlorine atom, and we will get sulfonine chloride. It's called sulfonine chloride. So this SO2Cl2 P4 plus 8 SO2Cl2 gives 4 PCl3 plus 4 SO2 plus 2 S2Cl2. Are you clear? So 8 sulfur atom, 4 here and 4 here. Are you clear? Then chlorine 16 atom, 8 to the 16. Value here, 4 here. Like PCl5 is also prepared. Just you have to take 10 S4 Cl2. Easily done. Are you clear? So this is nothing but the preparation of phosphorus pentachloride and as well as phosphorus trichloride. Are you clear? Okay. So this phosphorus pentachloride and trichloride. So what are its physical properties? What are its bond nature? So as you compare phosphorus trichloride and phosphorus pentachloride, it is more covalent. It is more covalent, and it is a pyramidal shape. You can find. See, this phosphorus atom and one lone pair Cl. If you go for the structure of PCl5, you studied this in first PUC. So it has three equatorial and two axial bonds. So Cl, and here is another Cl. See, these three are equatorial. These equatorial bonds are, the repulsion is less, and axial two bonds, more repulsion will have. This point you have to remember. See, axial bonds are away from the phosphorus atom due to repulsion, but equatorial bonds less repulsion, it is near. So this is nothing but structure of phosphorus pentachloride. So which is covered here. You can just pyramidal structure, you can sign, and it is nothing but a trigonal bipyramidal structure. Are you clear? This is nothing but the structure of phosphorus pentachloride and phosphorus trichloride. Phosphorus pentachloride is more covalent than phosphorus trichloride. Okay, we should go for its important reactions. See, phosphorus pentachloride reacts with certain organic compound which contains hydroxide OH that can be easily replaced, and certain chloride compounds you will get. Take for example, when it reacts with chemical properties of we should study chemical properties of phosphorus trichloride as well as phosphorus pentachloride. When it reacts with organic which contains hydroxide, Take for example, see CH3 COOH acetic acid. When it reacts with PCl3, so we will get see CH3 COCl. This hydroxyl group is replaced. Are you clear? And we will get see POCl3. So we will get PO. How many H atoms are there? There one. So therefore it is 3 times. That also it is 3 times. 3 times CH3COOH. So we will get H3 PO3. Are you clear? Listen here. See, 3 hydroxyl group is replaced here. 3 CH3COOH acetic acid when it reacts with phosphorus trichloride, main compound we got is, see, acetic chloride. We got here acetic chloride. And what is the other product? What is the chemistry of the remember here? Hydroxyl group is replaced by this chloride. Are you clear? Then, so you will get how many hydrogen atoms are there? 3. So therefore it is H3. 1, 3, 4, 3. 2 oxygen atom is 3. So therefore this is called phosphorus acid. It is called phosphorus acid. Okay, that's how. Very simple equation. Not phosphoric, it is called phosphorus acid, H3PO3. So when it reacts by PCl5, you can say CH3, COH, which is nothing but an acetic acid and carboxylic acid. When it reacts with phosphorus pentachloride, so you will get again CH3COC, acetyl chloride. The PCl5, which reacts with acetic acid, replaces the organic compound hydroxide. So you will get acetyl chloride. Now, so you will get POCl3, and plus HCl. So one chlorine atom is here, and other 3 chlorine atoms, and other 1 chlorine. Are you clear? Just check the balance in the equation. You have to be particular about the balance of the equation. See, CH3COOH, which is nothing but acetic acid. When it reacts with phosphorus pentachloride, how many chlorine atoms are there? 5 chlorine atoms are there. So you will get CH3COCl, which is nothing but acetyl chloride. Hydroxyl group is converted into chlorine. So it is therefore this phosphorus trichloride and pentachloride are used in the preparation of organic compounds. You will get phosphorus oxytrichloride then HCl. So these are nothing but the important chemical properties of phosphorus trichloride and phosphorus pentachloride. Again, you know its structure. Phosphorus pentachloride is, so it is nothing but two axial bonds are away because repulsions, equatorial 3 bonds are very near. So there were less repulsion. Due to less repulsion, they are very near equatorial. And axial bonds. In first phase we studied even its hybridization also. Okay, these are the important compounds and their chemical properties of phosphorus trichloride as well as phosphorus pentachloride. Are you clear? Okay, then we have to study different oxoacids of phosphorus. We have to study different oxoacids and their structure. So, different oxoacids of phosphorus. You have to remember the most important point is among oxoacids of phosphorus. See, oxoacids of phosphorus are, see, I write first H3PO4, which is nothing but phosphoric acid. Next, we have H3PO3, phosphoric acid, and H3PO2, which is nothing but hypophosphoric acid. Hypophosphorus acid. So you go for its structure and what are the chemistry of the remainder. See, I am going to write its structure, you can easily remember. One phosphorus atom is always double bonded oxygen. And all showing a tetrahedral structure. See, it is nothing but a tetrahedral. So, how many hydrogen atoms are free? How many oxygen atoms? So, therefore, it is nothing but OH. 3 OH. Tetrahedral. See, in any oxoacids of phosphorus, oxoacids of phosphorus, they must contain one phosphorus to oxygen double P double bond to O and one phosphorus to OH. Any acidic name, it must contain P2O1 double bond. Another one is P2OH. So any oxoacid of phosphorus, they contain P2O1 bond and next P2OH. So again, with oxidation state, we can find in pyrophosphoric acid, and we can find even phosphorus to phosphorus bond and phosphorus to H bond. It is possible. But both bonds are again not possible for any oxoacids of phosphorus. Okay? We shall concentrate its structure. Then we shall go for, if you wrote easily the structure of phosphoric acid, we can easily write. One you have to do. See, this is nothing but H3PO3 and phosphorus, which is with oxygen, again tetrahedral nature. So this is nothing but one OH and another two are OH. Are you clear? See, how many P2OH bonds are in phosphoric acid? 3. How many P2OH bonds are there in phosphorus acid? 2. By knowing the structure, you can easily understand. You must know how to draw the structure. So if you go for, say, H3PO2, hypophosphorus acid. So again it has double bonded with oxygen, again tetrahedral nature. Only one OH bound and P2OH bond. So remember, in oxoacids of phosphorus, P2OH bond, it cannot break. Only the hydrogen atom, which is OH, P2OH, that hydrogen can accept. That point you have to remember. And we shall find the folic metaphosphoric acid. So which is nothing but H3PO3 n times. So it is nothing but a structure. See, phosphorus along with double bonded oxygen and nitric continuous. So it is nothing but a 3 times oxygen, which again it is electric, another phosphorus, nitric continuous. So we shall continue with that discussion in this class. Are you clear now? So I wrote only the 3 structures here. Other structures we shall study in next class. And some of the chemistry behind this is oxoacids of phosphorus. I told you today only 3 acids and that structure. Clear? One is H3PO4, another one is H3PO3, another one is H3PO2. What is H3PO4? So it is nothing but phosphoric acid. It contains 3 P2OH bond and orthophosphorus acid. It contains, say, 2 P2OH bond and 1 P2OH bond. Another hypophosphorus acid, which contains only 1 P2OH bond and 2 P2OH bond. So, what are the chemistry behind this? Any oxoacids of phosphorus, they must contain P2 double bond O 1 molecule. 1. Another one is P2OH is compulsory. Again, with the different in oxidation state, they may contain even phosphorus to phosphorus single bond or phosphorus to H single bond. But any oxoacid, they must contain a common 2 bonds. Those are, one is phosphorus to oxygen double bond, another one is phosphorus to OH single. That we have to remember. So oxoacids, they are good reducing agent like hypophosphorus, which will continue discussion in the next class. So by another half an hour we are going to complete 15 group elements and I'll send you the notes. Okay, thank you. Good. Consider I mean, you over there,